It's doing its little thing slowly. Oh man, is this exciting or what? I can watch this all day. Welcome back to the Magnetic-Idex channel. I think I have something new for you that might be quite interesting. I wonder if this is the CoreXY killer. Let's find out. What am I up to today? Okay, first layer is nothing special, but you might already see something. This is a variation on the Slice Engineering flow test model. I just made a few changes to it. I wanted a long, continuous run as well, not just lots of turns. Surely this is not a CoreXY killer right now, is it? Let's see, what are we at right now? Oh, the sound of those motors. They are singing. So let me give you a quick background to this while this is building up to the point where you can see something. Let me bump the temperature up. It's a little bit under extruding. I think for this speed, I need to get a little bit more heat into that plastic. Got some under extrusion. Maybe I jumped the gun. Let's see. Is it recovering? I wonder if this is PA tuning that's interfering here. Maybe I'm just going a little too fast. It's okay. This is not about printing right now. So I'm maxing out at 195 millimeters per second. This is all happening in real time. I haven't done any tuning on this. This is literally my second print of the ZGX mod on the Akula 3 motion system. So this is a bolt-on mod. And you're asking, well, what did you do? What I did was I removed the stepper motor from the Gantry. So this motor is 226 grams. To be fair, I've been running the slider motor, and that's about 131 grams. But I've been able to reduce this down to 22 grams. And so I have all the benefits of CoreXY and none of the hassles or headaches of long belts, insane number of pulleys, and just complex resonance problems. What is this ZGX design? That's my working title. That might change. It's inspired by the zero gravity extruder. If you're familiar with it, you will know exactly what I'm talking about. I'm going to take the camera mobile and show you what is going on with the x-axis. On the surface, everything is same old Akula 3 motion system. And if you look deeper, we have this coupling replacing the motor. So I have a full-size stepper now mounted on the frame, and the coupling is doing all the work. So I did install, by the way, a brand new 1.5 GT belt. So that is a finer belt, same basic pulley diameter. My config changed ever so slightly. I went from 32 millimeters per revolution to 31.5. So virtually no change in my resolution, but I'm a little happier that the finer pitch belts are more happy making such a tight turn. So this is a 21 tooth 1.5 pitch pulley. You may have seen the model on printables, but in fact I ended up printing my own pulleys, partly because this is a brand new part right here. This is quite magical actually, just to look at that shaft. Square shaft is doing all the work, and my y-axis is now in total 422 grams lighter. Why 422? Because I switched these rails, the X rails, from steel to aluminum, and that gave me 218 gram weight reduction. And then the stepper motor changed from, I'm gonna call it from the original 230 grams down to 22 grams. So that's total of 422 gram weight reduction. I'm going to go ahead and slow this down a little bit more. I don't need to do this crazy race. 70% of my original speed. See what that looks like. On screen it looks like it's peaking out at 136. We'll let it run at this speed. And my acceleration is 10K. It's repetitive and boring. So I'm going to let it finish, but off camera, and then I'm also going to show you the speed test macro when we're done with this. For my American friends, the total weight reduction on the X Gantry is almost a full pound, 0.93 pounds, 422 gram weight reduction. That's coincidentally, that's the weight of a X1 carbon tool head. So it's, imagine taking a full extruder off the machine. Ultimately, it's not going to be simply about speed, it's going to be about the quality of the prints, even at common everyday speeds that you may be used to on modern printers. Let me zoom in a little bit. So you can see it's not pretty. I got a clearly PA tuning issue, I think. Correct me if I'm wrong. That's not an extrusion problem, that's a PA problem. It gets better as I slowed it down. I just need to tune PA at this speed. This may be a better look. Almost weird how quiet it is. And then again, back to the coupling. I've been working on this coupling on and off for about 8 years now. And when I finished designing Piccolino, I was like, I need a faster printer for Piccolino. And so that gave birth to Akula 3. And then, well, there's still a little bit left on Akula 3 that I really want to try. So I made this kludgy adapter. So it's literally a dummy motor, bolts right onto the existing system, complete bolt-on solution. And yeah, the tricks I did on Piccolino are in this 22 gram coupling. That's fully loaded with 6 ball bearings plus 2 larger ball bearings. So total 8 bearings replace all of the complexity of a CoreXY motion system. That's what it looks like from here. Just beautiful. Simple and beautiful. See how we improved our print quality? Yeah, when I reduced it to 117, it's pretty nice. Or it's a starting point. It's a starting point for tuning. So again, don't throw away baby with the bathwater. I'm just getting started, but I think this design has a huge potential. Let me know what you think I should call this. Zero Gravity X, ZGX, or should I come up with a different name for this motion system? Of course, I'm saying tongue-in-cheek, the end of CoreXY, the end of CoreXY. There's a place and time for everything, so bed slingers still exist, Ultimaker Gantry still exists, what do they call it, Cross XY or something like that. The hybrid CoreXY exists. There are so many different things. H-bot even exists. CoreXY was trying to improve upon H-bot. And I think I'm trying to improve upon CoreXY Gantry. Just make it lighter, simpler, cheaper. Imagine all the complexity of CoreXY is inside a tiny 22-gram coupling assembly. ZGX coupling. I kind of like the sound of it. Let's do a speed test macro. Cancel this print. Oh, by the way, you want to see how I can cancel the print? I can just move this over to the side, like so. Let the coupling do its thing. Hit emergency stop and park the tool. So that's a getaway of fixing things. Let me restart the firmware. So you can see the print is pretty nice. This is PLA. Ivory color, kind of like it. Ivory color, kind of like it. And you can see clearly a PA tuning issue, but not a problem overall. And the fact I can't tell the difference here when I start at 200 versus ending at 130. I'm going to show you speed test macro from this point of view and then from the zero gravity coupling point of view. So this is 350 at 15,000 acceleration. We'll let it finish and then I'll do the other part. This is crazy. Wow. And crawl to the... Oh, really quickly, why did I make the homing so slow? Because at the end of my prints, I just send it at max speed, tool 0, down to as close to the homing switches as possible. And the bed, I drop it close to homing position. At the beginning of the print, Clipper can take its sweet time, homing each axis individually. So I send X, Y home together and then Z separately. It still cuts a lot of time off, and I'm very happy about that. So let's see. What does the kinematics show us? Let me switch to console. So my X steppers, I have a step loss of 1, and my Y's remain the same. So yeah, 1 step is inconsequential. It's actually not a full step, it's whatever microstepping I have set. Let's do the same thing and rerun the macro, but I'll take the camera handheld again and we'll do the same test. Let's do it a little bit faster, 375. How about that? 375 at 15,000. Okay, send it. And we'll move over here. It's doing its little thing slowly. Oh man, is this exciting or what? I can watch this all day. That's insane. This part is whipping around a little bit, but it doesn't matter because everything's constrained on that single component on the coupling itself. So I may dampen it, put a little bit of a bearing here or something, or maybe try to figure out if I can straighten the shaft. Not a big deal right now. It's working really, really well. That was the LS speed test macro, modified for my machine. Let's check the console one more time. So my initial stepper value was 10,180 and it ended up with 10,180. 1466, 1467 on the Y. So again, a 1 step difference. That's pretty epic. negligible and does not contribute to any accuracy loss. So I'm pretty happy overall. Do we want to do one more speed test? Let's do 380 millimeters per second at 15K, and I'll take it mobile for a second. Let's see one more time. How about this view? You can see the zero gravity square shaft. That's insane. Obviously, I probably still have a long ways to go to get everything just perfect, but this is literally my first assembly of this prototype. Up to this point, I was always working on individual components and primarily the coupling, the zero gravity coupling. But once that breakthrough happened, once that thing clicked in my mind exactly how it's supposed to deal with backlash, that was the key. Without Piccolino, this would never been possible. And believe me, I tried really hard to make this work. So this particular test, CU stepper position was identical between the initial homing and final homing. So at most I've seen one microstep error after the test. I'm pretty excited about this. I hope you're too. Like, share, subscribe, follow me on Ko-fi. Bye everybody.